In 1.6, we're going to learn a different type of factoring. But before we get to the sum and difference of cubes type of factoring, the first thing I need to show you is how two things multiply each other. If I were to ask you to expand the following and combine like terms, this is not this method. This is going back to section 1 when we multiplied things. This is what it would look like. What you would do is you would take this first term, since it's a binomial multiplied by a trinomial, you would take this first term and multiply it to all three things. And what you should have had on your paper, x times x squared, is x to the third. And then an x times negative xy would be negative. You have two x's, x squared y. That's the product. And then what you should have had is plus xy squared. That's the first piece multiplied by all three things. The second piece, which is the y, is going to also multiply all three things. I'm going to do this in blue. When I multiply y times x squared, I can write that product in any order. So I'm going to put plus x squared y, and I'm going to keep it in alphabetical order. I'm going to put plus x squared y, and I'm going to intentionally put it right below this x squared y. Minus x, there's two y's, so xy squared. Last times the last would be plus y to the third. So if you were to actually FOIL this thing out or multiply it all out, you would get these six things. Now let's put these six things together. X to the third. Adding these together makes 0. Adding these together makes 0. Adding things together makes y cubed. What this should show you is we can get the second and the third and the fourth and the fifth terms to cancel out. There are 4 terms that will cancel out because of this plus sign and this minus sign. And this end product is something that is to the third power and something to the third power. Mathematicians a long time ago figured out that if you have something to the third plus something to the third, that you can factor it using this pattern. This pattern will break it and turn it into multiplication. And this pattern doesn't just work for adding cubes, it actually works for subtracting cubes. So what we have is this. We have 2 patterns that I would recommend that you write down in your notes. The 2 patterns look like that. It's the sum of cubes, which is the top one, and the difference of cubes. Okie dokie. I'm hoping you have this pattern written down. That's all it is. It's a pattern to turn something that has addition or subtraction of cubes can turn into multiplication using this pattern. This type of factoring is the factoring of the sum of cubes or the difference of cubes. Sometimes the factoring is called factoring using SOAP. Now, I had a student who came up with his own way. This was about 2 years ago. A student said, memorize this pattern by coming up with this little acronym. A boy ate too many apples but barfed twice. And I was like, what do you mean? He says, a boy ate too many apples but barfed twice. And I said, okay. So I've never heard anybody say that. I don't know if somebody else taught it to him in a different place. And I thought that was an interesting way to memorize this formula. I have it memorized in a different way. I'll show you how I have it memorized in a little bit. But if this helps you, do it. There's also the reason why it's called SOAP is because if this is a positive sign, you would have the same sign for the first two objects. You would have the opposite sign for the second two objects. In between the third space, it's always positive. It works for both of these things. And then the last thing that I have here before we get into examples is that a to the third plus b to the third is not the same thing as a plus b in parentheses to the third power. You have to understand that the mistake that we talked about with the squareds is going to be different than the mistakes. This is such a common mistake. Let me explain. If you have a plus b to the third, it means a plus b times a plus b times a plus b. You have three factors, right? Now up here, when we have this, remember how we have a plus sign and a minus sign? And that I showed you way over here that a negative sign and a positive sign and a positive sign and a negative sign makes these things cancel out in the middle, which is why we have this. What happens if those weren't negative and a positive? What happens if they weren't the opposite signs right there in the middle? Then they wouldn't cancel out. That's what's going to happen with this. If I were just to look at the first two terms multiplying, these two terms here, I'm going to put them in red. It would become a squared plus 1ab and another ab is 2ab plus b squared. That's what that red piece would FOIL out to be. And then what you would have to do is you'd have to multiply that by another a plus b. And as you go and you multiply that out, since the signs are all positive, let me show you what it's going to be. Just trust me on this. It's going to be a to the third plus 3a squared b plus 3ab squared plus b to the third power. That's what it expands to be. And the reason is because these two middle terms, imagine what would happen if you had two of them and one of them would make 3 and two of them and one of them would make 3. They don't cancel out because they're not a positive and a negative. These aren't the same thing as each other. You can't factor this with the same method as you do with this. Okay? All right. Just so you know. Make sure you know those are different. Okay. Now going back to this pattern. The way that I memorize this pattern is simple. A lot of times I think of it as a box. A box that's empty and a box that is shaded. If I know this pattern, there's 1, 2, and then in this other parentheses, it's going to be this box squared. The shaded box is squared over here, shaded, squared. And then the product of these two things is in the middle. Now if I remember that, and same, opposite, always positive, that's exactly how I remember the pattern. I think of a box, I think of squaring the box for the first part, think of squaring that box for the second part, and I think of these two things multiplying to be the third. If that doesn't work for you, then maybe you want to use this, or maybe you just want to memorize the formula. It's up to you. You get to decide what you want to do. Let's get to some examples. Number 4. Is this a perfect cube? Is 1 a perfect cube? Can you think about 1 being in terms of something to the third power?
Yes.
If I wanted to write this as a perfect cube, could I write it like this? Is it equivalent?
Yes.
Then guess what? We can factor it using the sum of cubes. Here's how you do it. You're going to set up a parenthesis and another parenthesis. There are going to be 5 slots. 1, 2, 3, 4, 5 slots. Using the pattern. You look at this first cube and you think about what is the cube root of k to the third, and that's what goes here. What letter goes here? Say it out loud. Okay. Then, because this is a number, we go to the back of this parenthesis, and we know that the cube root of 1 to the third is the number that goes here. What number goes here? Say it out loud. I agree. And then, because I know the pattern in terms of those boxes and the squares, as I was showing you earlier, I know that I need to take this and just square it, and take this and square it, and then multiply those two things for the middle. So I take this one and I square it. What is that going to make the front of this to be? Say it out loud. K squared. I'm sorry, I was supposed to say k squared. This times this is going to give us that k to the third. What I usually will do next is I go over to this last blank and I will take this one and I will square it and simplify it at the same time. 1 squared is 1. And then to get this blank here in the middle, I just multiply these two things. Simplify it, it's just k. And then I use same for this blank, opposite, always positive. I use SOAP. Same, that means it needs to be the same sign as what we started with. Plus. Opposite of a plus is minus. AP stands for always positive. This should be a plus sign. And this is your final answer, factored. You could FOIL it all out if you would like to. It will equal k to the third plus 1 because of that opposite sign. Those 4 things will cancel out. If you don't trust me, then try it. Let me say something else for the record. This piece here, some people might ask me, because they have asked me in the past, cannot factor further. There is nothing that can multiply. People have asked me, Mr. Prama, what if I did a k and a k and a 1 and a 1? I know I can get k squared. I know I can get a 1. I said, but what about this? If this was a minus and a minus, you would get negative 1k and negative 2k. It doesn't equal that middle term. It doesn't work. It never factors further. Can't. It can never factor further. This piece here, though, might factor further. And that's maybe a super challenging type of problem. This might. This will never, because this is too small. It needs to be twice as big, otherwise it won't factor. Okay? So that's how it works. Let's do a couple more examples and let's show you how it gets a little bit harder. We'll go a little bit faster this time. I have a to the third and a b to the third. I bet you know what that is, to the third power. I bet you know what the cube root is. I usually just write it like this. Parenthesis ab to the third. That way I kind of know what the cube root is. It's just going to be the a and the b. And then what I do is I set up my slots for the 5 slots. I got like front, back, front, middle, back. Front, back, front, middle, back. I look at my first cubes. I take the cube root and I write them here. Guess what? There's 2 of them. What 2 letters go right here? AB. I look at my last term. I take the cube root and I put that letter right here. What letter do I use? Yep. And now we just follow the pattern. We take this, I square it in the front, and that means you have to square everything. AB times AB is A squared B squared. Makes the most sense right now. We'll simplify that. I usually will go to the back because in order to get to c to the third, I need the c times something squared, which is c squared. And then to get to this middle term, I just multiply these 2 things and I get easy as 1, 2, 3. A, B, C. Easy as 1, 2, 3. Same is negative. Opposite of a negative is a positive. Always positive. This type of factoring is not that difficult. It's a matter of knowing a pattern and recognizing cubes when you see them, and knowing how to find cube roots, or what's something times itself times itself. How does it get harder? The numbers get a little bit bigger, like number 11. We have 27j to the third minus 125k to the third. It might be easier for you if you thought 27 is what to the third power? Do you know? Good. You might want to think of it as a 3j to the third power. I usually will write it in parentheses to the third power. And the same thing for the other one. What is this to the third power? Something k to the third in parentheses. What number? 5. Good. And then what I like to do is go right into my parentheses. I want the cube root of this. What is it going to be? I agree. The second thing is going to be what? Say it out loud. I agree. Then what I do is I go to this first thing, which is based off of the left thing, the 3j, and I have to square it, but I'm going to do that in my head. I have to do 3 squared and the j squared, and I simplify it. So what is that going to be? 9j what?
Cube. Or no,
Squared.
squared.
9j squared. I do the same thing with the 5k. I have to square that in the back. Back times the back. And when I square it, I think of the 5k times 5k, which is 25k squared. And then there's going to be a middle term here, which I just multiply these 2 things together. The 3j times the 5k. 3 times 5, 15. jk. No, seriously. JK. No, seriously. Oh, you guys don't get my jokes. Okay. I tried. Same. JK. Oh, gosh, you guys. Third period. Same. Opposite, always positive. This will never factor further. I can look to see if this factors further. It doesn't, but it is factored. This will multiply out to be the difference of those cubes. I mean, there's not a lot of work to do when you know the pattern. The last example is number 12. Can you incorporate things from section 2 when there's a GCF? Yes. Can you incorporate other things as well? Yes. Sometimes you might have to do difference of squares. I want to say your third problem, you might use difference of squares, and a different problem, you'll use cubes. So, is there a GCF of number 12?
Yes.
What is the GCF?
15.
And I used to ask you, oh, you pulled out the GCF, is there a difference of squares? No. Is there a sum of cubes? We can now factor this c to the third plus 1. We can factor it further. Don't forget the 1 pointer. I call that a 1 pointer because some students, the 15 just disappears. It stays in front of all of your parentheses. I bet you know what letter goes right here. I bet you know what number goes right here. What letter and the exponent that goes here? The number simplified over here. And then what I do is I multiply these two things and simplify it, so it should just be the letter. And then we do same, opposite, always positive. This will never factor further. We're going to stop your notes right there.